Alright, last video of the day, organic compounds. Again, now that I have a little bit of time, I'm able to get these videos together for the acids, bases, the organic compounds and the solutions, the material that we covered in Unit 8, the kind of the leftovers from chemistry. Organic compounds in particular, we have to know about these is related back to Unit 2, physical and chemical properties, how the properties of a substance determine its uses. That's really all we have to know about the organic compounds. We have to know how their properties dictate the way our bodies use them and dictate the way that we use them in our everyday life. First of all, organic compounds are compounds based around the element carbon. Almost every compound that contains carbon is an organic compound. There are some exceptions like carbon dioxide, CO2, that is not an organic compound. It's produced by living organisms but not considered organic. These will include things like sugars, starches, fats, proteins, things like that. That's where our organic compounds come from. Because they come from living organisms, they get this word, this name, organic. The properties of organic compounds, again, determine how they're used by living organisms, what we use them for in our bodies, what we use them for in our day-to-day life. Let's start with carbohydrates. Carbohydrates are the sugars and starches. Carbohydrates, one of the properties of a carbohydrate is that they are high-energy molecules. When we get to our physics, we'll talk about the different types of energy. One of those types would be chemical energy. What we'll learn there is that chemical bonds are like little batteries. They store energy inside of them. When we break those chemical bonds, we release that energy. We talked a little bit about that with endothermic and exothermic reactions. When we break bonds, we release the energy that's stored in those bonds. Well, carbohydrates have a lot of bonds. They're long chain-like molecules. They have a lot of carbon-to-carbon bonds in there. They have a lot of carbon-hydrogen bonds in there. And those bonds store a lot of energy. That high amount of energy is the property that dictates the use. Our body uses it for fuel. Glucose is our body's only source of energy. It is a carbohydrate. What our body does is break those bonds in the glucose to release the energy that's stored within them to fuel our bodies. High energy molecule, used for fuel. A property dictating a use. Lipids, those are fats and oils. Very similar to carbohydrates, except they store even more energy. Fats store a lot more energy than carbs do. So that property will dictate its use. Because you can store a whole lot of energy in those chemical bonds, our body will use these lipids, fats in particular, to store energy. Our body is great at surviving. You know, a lot of us get 3 square meals a day. Some of us don't. Our body never knows what it's going to get. So our body doesn't waste energy. If we eat more calories than what we need, if we eat more energy than what we need, our body will convert all that extra energy into fat. It will use that fat to store that energy because that fat can store a lot of energy. These are the energizer batteries of our body. They can store a lot of energy. They can pack it away for later. That's what they do. Again, a property dictating a use. Proteins. Proteins are long chains of amino acids. They're polymers. A polymer is a long chain-like molecule. The little pieces, the amino acids, are called monomers. It's like a paperclip chain. The individual paperclips are amino acids. The proteins are the chain, the whole paperclip chain. They're long, strong chains of amino acids. We can make these things very long. They can twist together. They can knot together to make very strong structures. That strength is what gives us our use. One of the uses, one of the many uses of proteins, is in muscle tissue, to give it that structure, to make up those cells. The reason why muscle tissue is so strong is because proteins are strong. It's the property dictating the use. And again, this is just one use of proteins in our body. There are others. This is a good one, though, to understand how a property dictates a use. If it's a long, strong chain, make things that need to be long and strong, like muscles. Hydrocarbons, the last group, very high energy molecules, sort of like carbohydrates, except these contain only carbon and hydrogen. That's why they're called hydrocarbon. Hydro for hydrogen, carbon for carbon. Difference, though, between these and the carbohydrates is that these are toxic, so we can't eat them. But we can use them. Just like carbohydrates, they store a whole lot of energy, very high energy molecules. Again, in all those bonds between the carbons and the hydrogens, there's a lot of energy in there. When we burn these, we release that energy, and we use that energy then to power our lives in a lot of cases. We burn these things as fuel. Gasoline, propane, natural gas are all hydrocarbons. The octane that's in gasoline is the hydrocarbon. We can't eat it for fuel, but we can put it in our cars for fuel. Propane, what's in our gas grills, again, we can't eat that for fuel, but we can use it to power our grills and cook our food. Natural gas is the stuff that's piped into our homes for gas water heaters, stoves, etc. Again, we can't eat it or inhale it for energy. It would kill us, but we can burn it and fuel our lives. So again, lots of energy, that's the property dictating the use. This time, instead of it being our body that's using it, this time it's using it in our life, our day-to-day life. So not much to know about organic compounds. Again, it's not a huge part of our curriculum, very small part. It deals with the chemical and physical properties and their uses again. If you have any questions, please post them on the wall or ask me in class.